Laura Castellano will be the next speaker. She is from Genova Aquarium. She is a native from San Remo, so she's a Mediterranean product. She's
what?
She's a marine biologist, and she's graduated from University of Genova. She had been working at the Genova Aquarium since 16 years. And she's at present responsible of the Mediterranean and the cold water section at the Genova Aquarium, and she is leading a team of 10 persons. Laura is incredibly fond of all sports. She's very fit, and she likes cycling, hiking in the mountain, water sport, and most of all diving. It is constant this morning. Diving is really your passion. You told me yesterday that one dream is that you could get gills to breathe underwater. Huh? That's right. Okay. Laura is doing a very great job in Genova Aquarium. We have some connection with Genova, with Monaco, of course, and she's going to present a paper on extreme animals from Antarctic. Okay. We listen to you, Laura.
Thank you, Pierre. Good morning to everybody. I'm here to speak about this husbandry of Antarctic fish and invertebrates. This project started 8 years ago with the cooperation, thanks to the cooperation between Acquario di Genova, University of Genova, and the National Project of Antarctic Research in Italy. And thanks to this cooperation, we put together our knowledge with the aim to transport and to catch, transport, and these animals from the Antarctic to Italy. The Italian base in Antarctic is called Mario Zuccalli base, and is situated in the Ross Sea, near here. And this is the base, and people who went there work both at the base or on the Italica vessel to sample in the Red Sea. Ross Sea, sorry. This is a view of the base with the special grass, this huge elephant seal, and this is a view of the Italica vessel before leaving in the Ross Sea. How we collected these animals. First, at the base, they use gill nets, especially the ice fish were collected by gill nets, and or fishing, digging holes in the pack and trying to fish the animals in this way. And from the vessel, they use a skeleton bucket called agassiz, and this net allowed them to collect fish and invertebrates from the bottom, so benthic animals, and even diving. And you can imagine how difficult it is to dive in this water because there are around minus 1.2 degrees in the water. So they told me all the difficulties they have, and you can see even the one going in the hole to dive and to catch the animals. On the boat, on the vessel, they had this sort of tanks to store the fish, and at the base, the facilities they had were these small aquariums in which they could quarantine the animals and to choose the good one to send to Italy. How we transport these animals? You probably saw the poster that Lorenzo presented a few years ago about this with all the details, but anyway, this is the outline of a container. It's a normal container with the temperature control, and the temperature inside must be 0 degrees, and this is the outline, and inside the container, there were two life support systems. This is the P&I, and one was for the fish, and one was for the invertebrates. And connected with the two life support systems, there is a reservoir tank, that is this one in the middle, to do the water changes. And this is the container, how it looks inside. And what I would say is that this container had to face the very difficult sea condition, because once the animals were put in the container, it was closed and it was completely unattended for 40 days in the vessel. So everything has to work really properly and not move and not open, not fall down, because otherwise everything could die. And the life support system of the fish was provided of 2 tanks of 800 liters, 1 pump plus one spare pump, 1 sand filter, and 1 biological filter. As you can see here, the ice fish, in the second transport, they put some shrimps inside with the aim of to provide them some live food during the travel. And in fact, when they arrived, there were quite no more shrimps, so they ate them. And the invertebrate life support system is made by 6 cooler tanks of 40 liters, 1 reservoir tank, 1 pump plus 1 spare pump, and 1 sand filter. This is the list of the animals that were transported in 2003 and 2004, and the list and the numbers that we have till now. And as you can see, we could transport Cnidaria, Arthropoda, Echinodermata, Mollusca, Annelida, and Chordata. Some of the specimens, when they arrived in Italy, went directly to the university for research, but the most stay at the aquarium. Once the container arrived, and as I told you, there were 2 expeditions, one in 2003 and one in 2004. For the first expedition, we used the container as a curatorial area, because we were building the cold room for the exhibit, and it was not ready yet, because we didn't know even if the animals were arriving and if they were alive or not. So it was not easy to use it as a curatorial area, because it arrives in April and for all the summer, and the summer was so hot, 40 degrees outside and 0 inside. So to manage it was not so easy. And inside there were animals that we didn't know before, so we had to know these animals, to do the first essay to feed them, and but at the end we could. And then this is the cold room where we were building the exhibit. This part is the exhibit, and the other side is the curatorial area. And this is the P&I. And the biggest tank of the exhibit is 1 cubic meter. I have to say they are small tanks, and there are 5 tanks in the system. The biggest one is 1 cubic meter, and the whole system is 2.3 cubic meter, the exhibit one, while the curatorial area is around 1 cubic meter. This is the exhibit, how it looks from outside now, and as you can see, there is a sort of a ice column, and to introduce to the cold this cold area. And I have to say that this ice column is something that everybody like a lot. And these are the parameters that of the water and the photo period. And the most challenging parameter is the temperature of the water, because it's minus 0.6 degrees, and it's not so easy to maintain this temperature. And as a photo period, we try to give a photo period that is similar to nature, but of course not the same, because otherwise they will stay in the dark for months. So in summertime it's 6-hour light and 18 dark, and in wintertime it's 15 light and 9 dark. And we add 1 hour every we add 1 hour every 15 days to go from one photo period to the other. And the animals looks to stay in a quite proper way, I should say, because this is the cold room, how it looks inside, and everything is quite narrow, but it's everything is put in a very proper place. And what are the problems that we have to face with these animals? First is the feeding, because the most of the fish started to eat frozen food, but the ice fish, that masterpiece I would say, really didn't want to eat frozen food. So we had to find a food that could, a live food that could survive at 0 degrees. And so we did different essay, and for example, we discovered that the sea bass are the best for this attempt. And fortunately, after they start to eat a live sea bass, after a short time, it was possible to pass them, to convince them to eat dead food, so frozen food. So now we are not giving them any more live food. Then temperature. Temperature is quite difficult because to freeze the water, and we wanted to maintain, because some people say that it's possible even to keep these animals at a temperature that is maybe 1 or 2 degrees, but in nature is below 0, and so we really wanted to maintain the temperature below 0. And this give problems, for example, with the heat exchanger that doesn't change heat, but because it freezes. And so, for example, when we do the water changes, we have to stop the heat exchanger half an hour before, then to stop the system to do the backwash or the water changes, and then to start again the system and after the heat exchanger. Otherwise, if the water stays fixed in the heat exchanger, it freezes and it's very difficult to restart it. The same is with aeration, because we wanted to provide air in the tank, but with the humidity of the air in the small pipes, they freeze as well, and so it's quite impossible to have air stone in the tank. But we have to say that at this temperature, the oxygen is very, very high, so at the moment we don't have a problem with the oxygen concentration. The biological filtration took 3 months to start, and what we did is to use the sand that was inside the sand filter coming from the Antarctica, hoping that the bacteria inside there were still starting, and so maybe it was easier for the biological filter to start. And even the water sterilization. At first, the P&I there was not the sterilization system, but we had some problems with the animals, bacterial, the most were bacterial problems. And so we try with the traditional medical treatments, but at this temperature, the traditional medical treatments that we normally use in the aquarium doesn't work. And so we said, okay, here is really, quite always is better to prevent than treat, but here is absolutely necessary. So we said, okay, let's try to add the UV, and instead we say that the UV even at that temperature work. And so we had the UV in the curatorial tank, in the exhibit tank, and even in the makeup system, because even the makeup has a system. He has a pump, an heat exchanger, and the UV, especially to freeze the water before doing the water changes. And the last problem was the condensation on the acrylic, but this was quite easy to put some stream in front of the acrylic to avoid this problem, and we quite never have condensation on the acrylic. So under an husbandry point of view, what we do, we offer food to the fish once a week, and but I have to say that the fish doesn't eat once a week. They sometimes, especially the ice fish, don't eat for months, and then they start again. And while the invertebrates are fed 6 days per week with dry spirulina and flake food. And the cleaning is a normal cleaning of, we vacuum the tanks once a week, and we do 10% of water changes once a week. These are some pictures of our exhibit, how they look, and at your right you can see the ice fish that are probably the masterpiece, but even the other small animals are very interesting. And the particularity of these animals is that they nearly don't move. They move very, very, very slowly and not so often. Except when they eat, for example, the sea star, the red sea star, when they eat, they do a sort of pallet, a sort of balls of sea stars, and they eat all together, and this is very interesting to see. Then what is interesting, according to me, is that all these animals, not all, but a good number of these animals were the object of research. So some of them went directly to universities, I told you, like Adamusium colbecki and Sterechinos neumawieri, but some other, like the Trematomus pennelli and the bernacchi, were the object of study in the aquarium. For example, the Trematomus bernacchi was supposed to have a particular kind of feeding, and it was supposed to use the rotational feeding, and in fact we could demonstrate that it's true, because if you offer them a big piece of food, they attack the piece altogether if they are more than one, or better, sometimes one first and then the others. And they adapt this rotational feeding, rotating very fast to take piece of food from these big pieces. And this is probably due, for example, to the fact that maybe they have small dead animals in the sea, and they use as food, and so they use this technique. And what is even important is that in our tanks we could see some egg release, for example the Isiodracovelifer and the Colossandeis, that are the sea spider, that are very interesting, and the Neobuccini oetoni too. And last but not least, we had some breeding. The Echinopsolus acanthocola breed normally and spontaneously in the tank. And the ice fish that you can see, we could observe the courtship, the mating behavior, the egg release, the parental care, the development inside the eggs, and the larvae. And I have to say that this was completely unknown even to science. So nobody knew even the shape of the larvae. And all these data are under publication. And I have to say that I want to thank all my staff to do this good result, and you for your attention.
Thank you very much, Laura, for this presentation. Very incredible presentation. Any questions to Laura about this specific exhibit? No question? I have one.
Yes.
Do the public realize how much difficult it is to make these exhibits?
Sorry.
Do the public realize that it is difficult to do such thing and presentation?
No, I don't think so. They realize this. No, I don't think so. We are trying to explain them in a very good way. The eyes you can see when you arrive is to introduce them to this very difficult, extreme environment. But I don't think that the people can understand how difficult it is to do this.
Yes.
Maybe you must tell them directly that it's very difficult, but at the very first side they don't realize that it's very difficult.
Yes.
According to me. But
nice example, because climate is changing, and this kind of animals are maybe animals which will be affected by the climate change, and it's a good way to introduce this important issue.
Yes, of course.
Okay, Laura, thank you very much. No more question? Yeah, one question here.
Hi, I come from Spain. I am a aquamedic dealer for public aquarium supplier. Congratulations for your experience. It's very interesting. And I have a question about pH.
Yes.
I see the pH is so low. But my question is, first, are trying you to imitate the first pH, the same pH under the North Pole, or really you have to prevent the ammoniac from the more difficult to bacterial low temperature problems?
I was expecting this question because I would have done the same. And the pH is low because the people who went there and measured the pH said that the pH there is that one. It shouldn't, according to me, but that's why we are keeping the pH so low. It's not to prevent ammonia. It's because when they fish the fish and they measure the pH where they fish the fish, the pH was like that.
Okay. And what is the tolerance of temperature? You say minus 0.6, but we can go up
we keep minus 0.6. Our goal is to reach minus 1.2, but it's really difficult because of what I told you, because of the freezing of the heat exchanger. But the tolerance, I have to say that we didn't try, because we don't want to lose animals. According to other experience that are not so many, because according to what I know, there are 2 other places that keep these animals. The tolerance can reach maybe even 5 or 6 degrees, plus 5 or 6 degrees. So, but we in fact we really never had a temperature like this. Sometimes at the very beginning in the container, when you use it at a curatorial area, and while doing the water changes, sometimes we could reach 3 or 4 degrees, but just for a while, and then it went down. So I don't know exactly what is the maximum tolerance of these animals.
Okay, thank you. Congratulations again, Laura, and your team for this excellent work. Thank you.
Thank you.